Okay, hello, we are back, and this is, we're going to call this part 3. It's not a set of notes, I'm just going to do an example from the worksheet. And so the worksheet's examples is going to be about number 1, and what we have are aqueous solutions of potassium phosphate and calcium nitrate are mixed. You're asked for a molecular equation, a complete ionic equation, and a net ionic equation. So this is just practice, and we're going to start with our formula for potassium phosphate. We know potassium is K+, and phosphate is PO4 -3. So our formula here is going to be K3PO4, that'll be aqueous, and calcium nitrate, we have Ca+2, nitrate's -1, so CaNO3 2, aqueous. And then we're going to flip-flop who's with who. So potassium is going to end up with the nitrate. And calcium will end up with the phosphate. So we have to write Ca3PO4 2. And we have to balance those charges, which makes the calcium and the phosphate come up with the 3 and the 2 respectively. And then you would check our solubility rules and see that potassium nitrate is going to be the aqueous and calcium phosphate would be the solid because of its solubility. And then our complete ionic equation comes after we balance this equation. So we see that we have a 3 here for calcium and only 1 here. So I'm going to use a different color to balance with so it stands out a little bit. So we're going to put a 3 in front of the calcium nitrate. And then we have 2 phosphates here and only 1 here, so I'm going to put a 2 there. And then that gives us 6 potassiums and 6 nitrates, which means we need a 6 right there. Okay, now we're going to go on to the complete ionic equation. And remember, the subscript on a monatomic ion then becomes a coefficient. If there's already a coefficient there, you multiply them. So we have 2 times 3 gives us 6 potassiums, aqueous. And we have 1 phosphate here times 2, so we'll have 2 phosphates. 3 calciums. And 6 nitrates. So notice how I'm being really conscientious about showing the charge, showing the number of the ions, and showing the state of matter. Okay, I might have to squish this in a little bit over here, get everything together. And over here on the product side, we have 6 potassiums, aqueous, and 6 nitrates, aqueous. And then we have our calcium phosphate, which is our solid, Ca+2, and there's 3 of them, plus 2 phosphates. Oops, sorry, I totally messed that one up. Hang on. My bad. All I had to do was bring down the calcium phosphate since it's the solid. I was trying to show it as an ion. So we have Ca3PO4 2 solid. Okay, so just recognize that I did make that mistake. I was trying to show that separated, but it should be together because it's the solid. Okay, now we're going to identify our spectator ions, and they are the ones, of course, that stay the same from reactants to products. So potassium is one of them. Potassium is often a spectator, and then nitrate is the other one, and that also is a frequent flyer for the spectator ion. So for the net ionic equation, we're just going to bring down what's left over, the PO4 -3, aqueous, 2 of them, and 3 calcium plus 2, aqueous. And then we have our calcium phosphate solid, Ca3PO4 2 solid. So again, we just showed the ions that made the precipitate in the net ionic equation, but we showed their number in terms of balancing. We also showed their charge, and we showed their state of matter. So these guys go from aqueous, floating around in solution, to being solid together at the bottom of the solution.